Welcome to Milky Narratives. Tonight, set aside the noise of the day, breathe deeply, and let your thoughts drift gently among the stars. Together, we'll explore the quiet mysteries that lie beyond the edge of the known universe. Number 1. The galaxies that never stopped growing. Some galaxies have been quietly growing for billions of years, and they may never truly finish. Imagine visiting a city that has never stopped expanding. Every century, new neighborhoods appear. Old buildings merge into larger ones. Fresh roads stretch farther into the countryside. The city becomes larger, richer, and more complex. Not because someone planned it, but because it simply keeps welcoming new arrivals. Now imagine that city is larger than millions of trillions of worlds. Its buildings are stars. Its streets are rivers of invisible gas. Its borders stretch across hundreds of thousands of light years. And unlike every city on Earth, it has been growing continuously for nearly the entire history of the universe. Tonight, we'll explore one of the quietest truths hidden among the stars. Galaxies are not frozen snapshots suspended in space. They are living structures. They breathe in fresh material. They consume smaller neighbors. They build new generations of stars. Even after billions of years, many are still changing before our very eyes. Perhaps the Milky Way itself is not a finished masterpiece, but a work forever being written by gravity. When we first look at the night sky, everything feels permanent. The stars seem fixed. The familiar constellations return every season. The Milky Way arches gently across the darkness, just as it has for countless generations. It is easy to believe the universe has always looked this way, but nothing in the cosmos truly stands still. Every star moves, every galaxy evolves. Even the largest structures we can observe are quietly changing so slowly that an entire civilization could rise and disappear without noticing the difference. Galaxies are among the greatest examples of this cosmic patience. Although they appear complete in photographs, they are constantly building themselves. To understand why, we must travel back nearly 14 billion years, not to a universe filled with graceful spirals and glowing galaxies, but to a time when none of them existed. The early universe was astonishingly simple. There were no stars, no planets, no galaxies, only immense clouds of hydrogen, helium, dark matter, and light slowly spreading through expanding space. Tiny differences in density, far too small for any human eye to notice, would eventually become everything. Gravity began its quiet work. Wherever slightly more matter existed, gravity became just a little stronger. That stronger pull attracted more matter. The denser those regions became, the faster they continued growing. No explosions announced the beginning. No grand event marked the first galaxy. Instead, countless invisible streams slowly carried gas toward growing concentrations of dark matter. Over hundreds of millions of years, the first stars ignited. Small galaxies appeared, but they looked nothing like today's majestic spirals. Most were surprisingly modest. Many contained only a tiny fraction of the stars found inside the Milky Way. They were the infants of the cosmic family. And like all young things, they still had much growing left to do. One of the greatest misconceptions about galaxies is that they form once and remain unchanged forever. Reality is far more beautiful. Galaxies spend nearly their entire lives evolving. Every passing billion years writes another chapter. Some collect fresh hydrogen, drifting through the invisible filaments of the cosmic web. As this gas slowly falls inward, it cools, gathers into enormous molecular clouds, and eventually collapses under gravity. New stars quietly ignite. Entire stellar nurseries bloom, where previously there had been only darkness. Every newborn star becomes another tiny addition to a galaxy that has never truly stopped growing. Even our own Milky Way continues this gentle process today. Every year, new stars are born somewhere within its vast spiral arms. Some are small red dwarfs that may shine for trillions of years. Others are massive blue giants destined to live only a few million years before exploding as spectacular supernova. One generation replaces another. The galaxy quietly renews itself. Yet fresh gas alone cannot explain everything. Sometimes galaxies grow in a much more dramatic way. Imagine two snowflakes drifting slowly toward one another. At first, they appear completely separate. Eventually they touch. Then, almost impossibly gently, they become one larger crystal. Galaxies experience something remarkably similar. Across billions of years, neighboring galaxies slowly approach under gravity's influence. Their stars rarely collide directly. The distances between individual stars remain so enormous that most simply pass safely by one another. Instead, gravity gradually reshapes both galaxies. Elegant spiral arms stretch outward. Clouds of gas become tangled together. New bursts of star formation illuminate the darkness. Eventually, the two galaxies settle into a single, larger home. The universe does not destroy. It transforms. Astronomers have observed countless examples of these graceful mergers. Some galaxies display enormous tidal tails stretching hundreds of thousands of light years into space. Others contain double cores, evidence that two ancient galaxies are still completing their slow embrace. Every collision becomes another act of creation. The resulting galaxy often contains more stars, more planets, and even larger reservoirs of gas than either parent possessed alone. Growth continues. Perhaps nowhere is this process more impressive than among the largest galaxies in the universe. These giants often sit quietly at the centers of enormous galaxy clusters. Over billions of years, gravity has gradually delivered smaller galaxies into their vicinity. One by one, they have been absorbed, not violently, but patiently. Each new arrival leaves behind stars, gas, dark matter, and sometimes entire globular clusters that become permanent members of their new home. Some of these colossal galaxies have grown so large that they contain trillions of stars. Yet, even they may not be finished. The universe continues delivering new companions. Gravity never truly retires. Remarkably, growth does not always involve visible matter. Surrounding every galaxy lies an enormous halo of dark matter extending far beyond the stars themselves. Although invisible, these halos continue gathering additional material from the surrounding universe. Fresh gas falls inward. Small satellite galaxies become trapped. Invisible structure quietly expands long before visible changes become obvious. In many ways, galaxies grow from the outside inward. Their unseen foundations prepare tomorrow's visible beauty. There is something deeply comforting about this endless process. We often imagine completion as the goal of every journey. A finished building, a finished painting, a finished story. Nature seems to prefer something different. Forests continue growing. Rivers continue changing. Mountains slowly rise and erode. The universe shares that same philosophy. Its greatest creations remain unfinished. The Milky Way itself offers perhaps the most extraordinary example. Astronomers know that our galaxy is slowly approaching the Andromeda Galaxy, our nearest giant neighbor. Today, they remain separated by roughly 2.5 million light years. That sounds impossibly distant, yet gravity has already begun writing their future together. In about 4 to 5 billion years, the two galaxies will begin a slow gravitational dance. Their spiral arms will stretch, their stars will intermingle, their gas clouds will collide, igniting vast waves of newborn stars. Eventually, after billions more years, they will become a single enormous galaxy. To anyone living on a distant planet during that era, the night sky would be unlike anything we know today. Great rivers of stars would span the heavens. neighboring galaxies would appear distorted into magnificent arcs. Entire constellations would slowly dissolve as the architecture of the sky transformed around them. And even then, the story would not be over. The newly formed galaxy would continue attracting smaller companions. Fresh gas would still arrive from intergalactic space. Dark matter would continue shaping its invisible boundaries. Another chapter would begin. Perhaps this is the quiet lesson galaxies have been teaching all along. The universe never mistakes stillness for completion. Something may appear calm while changing profoundly beneath the surface. Something may seem ancient while quietly preparing its future. Every galaxy shining peacefully in the night sky is both a memory of the past and a promise of what has yet to come. It is not simply an object suspended in time. It is a journey, a patient masterpiece still under construction. And somewhere, far beyond the reach of our eyes, another tiny galaxy has just begun its own slow story. A story that may continue growing long after every familiar star in our own sky has faded into history. Number 2, the stars that drift without a home. Not every star belongs to a galaxy. Some have spent billions of years wandering alone through the darkness between them. Imagine looking up at the night sky and discovering there is no Milky Way, no familiar river of stars stretching across the heavens, no neighboring constellations decorating the darkness, no nearby suns quietly sharing the same galactic home. Only one star, your own. Its warm light still rises every morning. Its gentle glow still sets every evening. But beyond that single sun lies almost unimaginable emptiness. Millions of light years of silent darkness separate your world from the nearest galaxy. It sounds like science fiction, yet somewhere in the universe, such lonely stars almost certainly exist. They have no permanent galactic address, no spiral arm to call home, no bright celestial neighborhood surrounding them. Instead, they drift endlessly through the vast spaces between galaxies, crossing distances so immense that their journey could outlast the entire history of life on Earth. Tonight, we'll leave behind the crowded cities of stars we've come to know and follow these extraordinary cosmic wanderers, the stars that lost their homes, the planets that may still orbit them, and the quiet truth that in the universe, even loneliness can become a remarkable kind of journey. When we think about galaxies, we naturally imagine them as enormous families. Hundreds of billions of stars circled together, bound by gravity like dancers moving through an ancient choreography. Every star seems to belong somewhere. Our own sun is one among roughly 200 billion stars inside the Milky Way. It travels peacefully around the galactic center, completing one orbit every 230 million years. Most stars spend their entire lives doing exactly that, remaining faithful to the galaxy where they were born. Yet gravity is not only a force that gathers. Sometimes it lets go. The universe is constantly moving. Galaxies pass one another. Clusters slowly collide. Dark matter quietly reshapes invisible landscapes. Every close encounter subtly changes the paths of countless stars. Usually those changes are almost impossible to notice. A tiny adjustment here, a slight alteration there. But every so often, gravity performs something extraordinary. A star receives just enough energy to escape, not from its solar system, not from a star cluster, but from its entire galaxy. Imagine swinging a child gently on a playground carousel. Release your hands at just the right moment, and the child glides outward in a straight line. Gravity occasionally performs an astonishingly similar act on a cosmic scale. A wandering galaxy passes nearby. A close gravitational encounter unfolds. The star's orbit stretches farther and farther until one day, it simply never returns. Its long relationship with its galaxy quietly comes to an end. There is no explosion, no dramatic farewell, only a gentle departure that continues for billions of years. Astronomers call these remarkable objects intergalactic stars. Some prefer the poetic name orphan stars. Neither description is entirely perfect. After all, the stars themselves are not truly abandoned. They simply become citizens of the space between galaxies. Today, astronomers have found evidence for enormous populations of these lonely travelers. In giant galaxy clusters like the Coma Cluster or the Virgo Cluster, countless stars no longer belong to any single galaxy. Instead, they drift freely through the cluster itself, contributing to a faint glow known as intracluster light. At first glance, this gentle glow appears almost ghostly. It is not coming from galaxies. It is coming from stars that no longer have one. Their combined light softly illuminates the darkness between entire galaxies. Imagine millions of campfires scattered across a vast wilderness. Individually, they appear tiny. Together, they create a delicate glow stretching across the horizon. That is something like the appearance of intracluster light. It is one of the quietest reminders that galaxies are not permanent homes. They are places stars sometimes leave behind. But perhaps the most fascinating question is not what happens to the star. It is what happens to everything orbiting it. If a star escapes gently enough, its planets may never notice anything unusual. Gravity binds planets to their parent star much more tightly than it binds the star to its galaxy. As long as that local relationship remains undisturbed, the planetary system continues almost exactly as before. The sun still rises, the seasons continue, moons circle their planets, oceans reflect familiar sunlight. Life, if it exists, may continue peacefully for millions or even billions of years. And yet everything beyond that small neighborhood has changed forever. Imagine standing on the shore of an ocean beneath such a sky. During the day, nothing seems unusual. Clouds drift overhead. Your familiar sun warms the landscape. Birds, or whatever creatures evolved there, continue their ordinary lives. Night arrives. You look upward expecting thousands of stars. Instead, there are almost none. The nearest galaxy appears as a distant spiral, a tiny glowing island suspended in endless darkness. No bright Milky Way stretches overhead. No neighboring stellar families fill the sky. Only silence. The loneliness would be almost impossible for us to comprehend. On Earth, we have never experienced a truly empty sky. Even our darkest nights overflow with stars. Our ancestors created myths from them. Navigators crossed oceans using them. Poets found endless inspiration within them. Civilizations measured time through their movements. Now imagine growing up without any of that. An intelligent civilization living around a lonely intergalactic star might never realize galaxies even existed. Their telescopes would reveal only a handful of faint smudges scattered across unimaginable distances. The universe would appear strangely empty. Perhaps they would believe their own star was unique. Perhaps discovering the true scale of the cosmos would take them far longer than it took humanity. Sometimes knowledge depends simply upon where you happen to live. Yet these wandering stars carry remarkable memories. Every atom inside them was forged within a galaxy. The calcium inside rocky planets, the oxygen that might fill alien oceans, the carbon that could someday become living organisms. All of it was created by generations of earlier stars that lived and died long before the journey began. Although the traveler has left home, home still exists inside it. There is something quietly comforting about that thought. Modern simulations suggest that galaxies like our own have been exchanging stars throughout cosmic history. Small satellite galaxies fall into larger ones. Larger galaxies merge together. Some stars become permanent members of their new homes. Others are flung outward into intergalactic space. Gravity is constantly rearranging the universe, not through violence alone, but through patient movement. Every billion years becomes another opportunity for new journeys to begin. Even our own Milky Way contains streams of stars left behind by ancient galaxies it absorbed billions of years ago. Some of those stars have traveled extraordinary paths before finally joining our celestial neighborhood. Perhaps every galaxy is partly built from immigrants. Perhaps every great spiral is also a collection of ancient stories arriving from elsewhere. And perhaps that has always been the way the universe grows. Not by remaining unchanged, but by sharing, by exchanging, by allowing countless travelers to carry pieces of one place into another. One day, billions of years from now, when the Milky Way and Andromeda slowly merge into a single giant galaxy, gravity will once again begin redistributing stars. Some will settle into graceful new orbits. Others may be thrown into the immense darkness beyond. Future intergalactic wanderers are already hidden among the stars we see tonight. They simply have not begun their longest journey yet. Perhaps that is the quiet lesson these lonely stars leave behind. We often think that belonging depends upon staying in one place. The universe suggests something gentler. A traveler does not stop carrying its history simply because it leaves home. Every wandering star still carries the elements of its birthplace. Every planet still circles its familiar sun. Every beam of starlight still shines with the same quiet warmth it always has. Only the background has changed. And somewhere, in the endless darkness between galaxies, another solitary star continues its patient voyage. Crossing an ocean so vast that even after billions of years, it has barely begun the journey ahead. Number 3. The invisible bridges between worlds. The universe is filled with enormous bridges that no telescope can truly see, yet entire galaxies depend on them to survive. Imagine standing at the edge of a great canyon. Far below, a river disappears into the mist. Ahead, another mountain rises in the distance. There is no visible bridge connecting the two sides, yet somehow, travelers continue crossing. Supplies continue arriving. Entire cities survive because of pathways no ordinary visitor can see. The universe may hide bridges much like these, not bridges made of steel, not bridges built by civilizations, but enormous invisible connections stretching across millions of light years. They carry no cars, no people, no spacecraft. Instead, they quietly transport the very material from which stars are born. Without them, many galaxies would eventually run out of fuel. Their brilliant spiral arms would slowly fade. The birth of new suns would become increasingly rare. The universe would grow far quieter than it is today. Tonight, we'll follow these hidden bridges, roads that cannot be photographed in ordinary light, structures so delicate that humanity discovered them only recently. Yet they may be among the most important pathways ever created in the cosmos, because sometimes the things holding the universe together are almost impossible to see. If these peaceful journeys through the universe help you unwind after a long day, consider subscribing so we can continue discovering its quiet wonders together. For much of human history, galaxies appeared to be isolated islands. Each one floated peacefully through empty space, surrounded by unimaginable darkness. The Milky Way seemed alone. Andromeda seemed separate. Every distant galaxy looked like a complete universe unto itself. It was an elegant picture, simple, beautiful, and incomplete. As telescopes improved, astronomers began noticing something curious. Galaxies were not distributed randomly. Instead, they gathered into enormous families called galaxy groups and clusters. Even stranger, these clusters themselves seemed connected by immense filaments stretching across the observable universe. It was almost as though someone had woven an invisible web long before the galaxies themselves had fully formed. Today, astronomers call this enormous framework the cosmic web. Yet the glowing galaxies represent only its brightest decorations. The true structure remains almost entirely hidden. Between neighboring galaxies, enormous streams of hydrogen gas quietly flow through space. These streams are astonishingly thin. If you traveled through one, you would barely notice anything around you. The gas is spread so sparsely that each cubic meter contains far fewer particles than even the emptiest laboratory vacuum ever created on Earth. And yet, across distances of millions of light years, those tiny particles add up, slowly, patiently, continuously. Like gentle rivers feeding great lakes, these invisible currents deliver fresh material into galaxies. Gravity performs nearly all the work. Dark matter forms vast invisible filaments stretching across the universe. Ordinary hydrogen naturally follows those gravitational pathways. The gas drifts inward over hundreds of millions of years, guided along routes established shortly after the Big Bang. It does not rush. There are no roaring currents, no crashing waves, only a patient flow unfolding across timescales, almost beyond imagination. Eventually, the gas reaches a galaxy. As it falls deeper into the galaxy's gravitational embrace, it begins cooling. Clouds slowly become denser. Molecules form. Great stellar nurseries emerge. Then, almost magically, gravity takes over once again. Clouds collapse. Temperatures rise. Pressure increases. A new star quietly ignites. Every sunrise on a newly formed planet, every future civilization, every atom of oxygen waiting to become part of a living creature, may owe its existence to hydrogen that once drifted through one of these invisible bridges between galaxies. In a profound sense, galaxies do not simply create themselves, they are continuously being nourished. Astronomers sometimes describe this process as cold accretion. The name sounds surprisingly ordinary for something so extraordinary. Unlike gas heated to millions of degrees inside giant galaxy clusters, this hydrogen remains relatively cool as it travels along cosmic filaments. That allows it to flow efficiently into growing galaxies without losing its ability to form new generations of stars. For young galaxies especially, these hidden rivers may have been the primary source of their remarkable growth. Billions of years ago, the universe was far busier than it is today. Stars formed at astonishing rates. Entire galaxies blazed with youthful energy. To sustain such rapid growth, enormous quantities of fresh hydrogen had to arrive continuously. The invisible bridges quietly supplied it. Without them, many galaxies might have exhausted their fuel surprisingly early in cosmic history. Instead, the universe remained vibrant. The great spiral galaxies we admire today may owe much of their beauty to streams that almost no one will ever directly observe. Finding these bridges has not been easy. Hydrogen this diffuse emits very little visible light. For decades, astronomers suspected the bridges existed mainly because computer simulations predicted them. The mathematics repeatedly produced the same elegant network. Yet seeing them proved enormously difficult. Only recently have powerful instruments begun revealing faint traces of these hidden structures. Sometimes astronomers detect them because distant quasars shine through the gas. As the quasar's light passes across the invisible bridge, specific wavelengths are gently absorbed by hydrogen atoms. The missing colors reveal the presence of material that would otherwise remain completely unseen. It is rather like discovering an invisible window because sunlight passing through it changes ever so slightly. Other observations have revealed faint glowing filaments directly, stretching between neighboring galaxies like delicate strands of silk suspended across impossible distances. Each new discovery confirms that the universe is far more connected than it first appears. Perhaps the most beautiful example lies surprisingly close to home. The Milky Way itself is still receiving fresh material. Small clouds of hydrogen continue falling toward our galaxy from its outer halo. Some arrive from nearby satellite galaxies. Others may originate from larger intergalactic streams. Although the process unfolds extraordinarily slowly, our galaxy has never entirely stopped feeding. The stars that will illuminate Earth's distant future may begin their story inside hydrogen clouds, drifting toward us today. Even our own sun participates in a much larger cycle. It was born roughly 4.6 billion years ago from gas enriched by countless earlier generations of stars. Some of that material likely traveled immense distances before finally becoming part of the cloud that collapsed to form our solar system. The oxygen we breathe, the iron inside our blood, the calcium within our bones. Every atom carries a history extending far beyond the Milky Way itself. Nothing appears suddenly. Everything arrives through patient journeys. There is something deeply comforting about these invisible bridges. At first glance, galaxies seem isolated, separate, independent. Yet the universe quietly tells another story. Every galaxy depends upon relationships extending far beyond its visible boundaries. Fuel arrives from distant regions. Gravity connects enormous structures. Invisible pathways allow life itself to become possible. Perhaps separation has always been an illusion. The brightest islands of the cosmos survive because hidden connections continue nourishing them. Nature often works this way. Forests are linked by underground fungal networks. Coral reefs depend upon unseen ocean currents. Clouds carry water across continents. Life flourishes because invisible systems quietly support visible beauty. The universe seems to follow exactly the same principle. Behind every brilliant galaxy lies a hidden network. Behind every newborn star stands an invisible river. Behind every glowing spiral stretches a bridge no traveler will ever cross. And somewhere, far beyond the limits of our telescopes, countless more of these silent pathways continue weaving through the darkness, patiently carrying tomorrow's stars toward galaxies that have not yet finished growing. One invisible bridge at a time. Number 4, the places where light gets lost. Across the cosmos, there are regions where light begins an endless journey. But may never reach another living observer. Imagine lighting a candle in the middle of an endless desert. Its tiny flame glows faithfully. Photons stream outward in every direction at the fastest speed the universe allows. The light never slows. It never tires. It never chooses where to go. It simply continues its journey. Now imagine that no one is there to see it. Not today, not tomorrow. Not even after a billion years. The light keeps traveling, crossing oceans of darkness, passing silently between distant galaxies, only to discover that there is no eye waiting for its arrival. No planet, no telescope, no living creature, perhaps not even another star. It is a strangely beautiful thought. Every second, the universe creates unimaginable amounts of light. Yet much of it may spend eternity traveling through empty space, carrying stories that no one will ever read. Tonight, we'll follow these forgotten travelers, the photons that escaped their stars, the ancient beams that crossed billions of light years alone, and the mysterious places where light may continue wandering forever, unseen by any living observer. Whenever we look into the night sky, it is easy to believe that every star exists to be seen. After all, the light from our own sun reaches Earth every morning. The stars above us fill the darkness with familiar patterns. Even distant galaxies eventually reveal themselves through powerful telescopes. It feels as though light always finds an audience. But that comforting idea is almost certainly an illusion. The universe is unimaginably vast. Its emptiness is far greater than its brilliance. For every galaxy glowing in the darkness, there are enormous regions containing almost nothing at all. Millions of light years may pass without encountering another galaxy. Inside those immense voids, light continues traveling exactly as it always has, patiently, silently, without knowing whether anyone will ever receive its message. Every star emits photons in every direction, not just toward neighboring planets, not only toward nearby galaxies, but equally into the deepest emptiness. Imagine standing in the center of a great field during a gentle rainstorm. Raindrops fall everywhere, only a tiny fraction lands on your hand. Light behaves in much the same way. Earth intercepts only an unimaginably small fraction of the photons produced by the Sun. Most continue into interplanetary space, beyond the solar system, beyond the Milky Way. Some will cross the entire observable universe without striking anything substantial. Others may eventually disappear beyond the expanding cosmic horizon itself. Their journey continues, even if no destination remains. This is one of the quiet consequences of the universe's expansion. Space itself is growing. Galaxies are not simply moving through space. The fabric of space stretches between them. For nearby galaxies, gravity can overcome that expansion. But at the greatest distances, expansion wins. Entire galaxies gradually drift beyond one another's observable horizons. Their light becomes increasingly stretched. Its wavelength grows longer. Its energy slowly decreases. Eventually, the photons become so faint and so redshifted that they can no longer be detected by ordinary observers. The messages are not destroyed. They simply become unreachable. It is almost like shouting across an ever-widening valley. Your voice continues traveling. The air still carries every word, but the distance grows so rapidly that no listener can ever hear the sentence complete. The universe performs something similar with light itself. Cosmologists sometimes describe this as the cosmic event horizon. It marks a remarkable boundary, not a physical wall, not an edge of the universe, but a limit beyond which certain events can never influence us. Light emitted today from sufficiently distant regions may never arrive here, no matter how patiently we wait. Likewise, some of the light leaving the Milky Way this very moment will never reach civilizations living beyond those same horizons. Entire conversations between galaxies are quietly being interrupted by the expansion of space, not through violence, simply through distance. Yet even within our own galaxy, many photons live astonishingly lonely lives. Consider a single photon leaving a star near the outer edge of the Milky Way. Instead of traveling toward another star, it heads outward into intergalactic darkness. The nearest galaxy may lie over 2 million light-years away. The photon requires millions of years merely to approach it. If its path misses every planet, every dust cloud, every wandering comet, and every telescope, it simply continues onward, year after year, million after million, perhaps billion after billion, never interacting with anything at all. From the photon's peculiar perspective, however, the story becomes even stranger. According to Einstein's theory of relativity, light experiences no passage of time. A photon does not feel itself growing older. Departure and arrival become part of the same timeless event. If arrival never occurs, its journey, in a sense, remains forever unfinished. There is something wonderfully poetic about that idea. Some stories never reach their final page. Astronomers often rely upon fortunate accidents to observe distant light. Sometimes a beam heading generally toward Earth passes close to an enormous galaxy cluster. The cluster's gravity bends space itself, gently redirecting the light. This phenomenon, known as gravitational lensing, acts almost like a natural cosmic magnifying glass. Light that might otherwise have missed us entirely becomes focused toward Earth. Entire galaxies hidden behind massive clusters suddenly become visible. Without these gravitational lenses, many ancient objects would remain forever beyond our reach. It is remarkable to think that gravity occasionally rescues forgotten messages from the darkness. Even black holes contribute to this extraordinary story. Although nothing escaping from inside an event horizon can return, light passing safely outside a black hole still has its path bent by gravity. Entire beams curve around invisible masses before continuing their ancient journeys. To the photons themselves, nothing seems unusual. They simply follow the shape of space. the universe quietly edits their route without ever slowing their speed. There are also places where light becomes trapped for astonishing lengths of time. Inside dense stellar interiors, photons cannot travel freely. They bounce endlessly between charged particles. A photon born inside the sun's core may require hundreds of thousands of years before finally escaping into open space. When sunlight reaches your face, it may have begun its journey long before early humans ever walked the earth. Even familiar daylight carries an ancient history. Perhaps the greatest mystery is not how much light we see, but how much we never will. Every second, stars disappear beyond our observable horizon. Every moment, new photons begin journeys whose destinations may never exist. Entire civilizations, if they inhabit distant galaxies, are likely sending invisible rivers of light toward us right now. Most of those messages will never arrive, not because anyone chose to hide them, simply because the universe has grown too large, too expansive, too patient. There is something unexpectedly peaceful about this. We often imagine that every action requires an audience. Every story deserves a reader. Every light should illuminate someone's path. The cosmos gently suggests otherwise. A star shines because shining is its nature, not because someone is watching. Light travels because the laws of nature invite it forward, not because arrival is guaranteed. Perhaps there is quiet beauty in that endless faithfulness. Every photon continues its journey without hesitation. Every star gives its light freely to the darkness. Every galaxy writes messages into space, knowing nothing of who may someday receive them. And somewhere, beyond the farthest galaxies we can imagine, countless ancient beams of light are still crossing the silent universe, carrying stories that began billions of years ago, stories that may never reach another living observer, yet continuing their endless journey, all the same. Number 5. The giants sleeping beyond the stars. Some of the largest objects ever discovered don't shine, explode, or even move very much. They simply wait in the darkness, shaping everything around them. Imagine sailing across a calm ocean at night. The water appears perfectly peaceful. The stars reflect softly on the surface. Nothing seems unusual. But beneath your ship rests a mountain larger than any on Earth. Invisible, silent, its enormous presence quietly redirects every current flowing around it. You never see it, yet everything nearby responds to its gravity. The universe hides giants much like these, not blazing stars, not spectacular galaxies, not violent black holes swallowing everything in sight. Instead, there are colossal structures so enormous that entire clusters of galaxies slowly orbit around them. They rarely announce themselves. They produce almost no light. They simply remain where they are, patiently influencing everything nearby across billions of years. Tonight, we'll meet these sleeping giants, the largest invisible kingdoms ever discovered. Ancient structures whose gravity quietly organizes vast regions of the cosmos. Because sometimes, the most powerful rulers in the universe are also the quietest. Whenever we picture something enormous in space, our minds naturally drift towards stars. After all, stars dominate our skies. They burn brilliantly. They explode dramatically. They fill galaxies with light. Yet stars, impressive as they are, represent only tiny pieces of a much larger story. Even galaxies themselves are surprisingly small compared to the greatest structures gravity has assembled. As we journey farther from the Milky Way, individual galaxies begin gathering into families. Our own galaxy belongs to a modest collection known as the local group. It contains dozens of galaxies held together by their mutual gravity. The Milky Way, Andromeda, the Triangulum Galaxy, hundreds of smaller dwarf companions. Together they drift through space as one enormous gravitational community. But even this family is only a neighborhood. Far beyond the local group lie galaxy clusters. Some contain hundreds of galaxies. Others contain thousands. Each galaxy carries billions of stars. Each star may possess planets. Each planet follows the quiet rules of gravity established long ago. The scale becomes almost impossible to imagine. Yet even galaxy clusters are not isolated. They belong to something still larger. Across the universe, immense concentrations of galaxies gather into structures called superclusters. These are among the largest recognizable arrangements ever discovered. Rather than neat spheres, they resemble sprawling continents stretching across hundreds of millions of light years. Our own local group belongs to one known as Laniakea, a beautiful Hawaiian word meaning immeasurable heaven. The name feels wonderfully appropriate. Laniakea contains roughly 100,000 galaxies. Each follows invisible rivers of gravity toward enormous central regions over timescales measured in billions of years. Yet, calling Laniakea a structure can be slightly misleading. Unlike galaxy clusters, many superclusters are only loosely bound together. The expansion of the universe is gradually pulling them apart. Even giants cannot resist everything. But within these immense regions lie places where gravity has quietly ruled since the universe was young. At the hearts of many galaxy clusters live enormous elliptical galaxies. Unlike graceful spiral galaxies, these giants appear smooth and rounded. They possess little fresh gas. Few new stars are born inside them. Most of their stellar populations are incredibly old. Astronomers sometimes call them fossil galaxies because they preserve memories of the universe's earlier history. Yet, despite their peaceful appearance, these galaxies have spent billions of years quietly growing. Smaller galaxies slowly fall toward them. Gravity gently tears the newcomers apart. Their stars spread outward, becoming permanent members of the larger galaxy. Again and again, the process repeats. No dramatic collision, no cosmic fireworks, only patient accumulation. Like snowflakes settling onto an ancient mountain, the giant simply becomes larger. Some of these central galaxies now contain trillions of stars. The Milky Way, magnificent though it seems to us, would appear surprisingly modest beside them. If our galaxy were placed inside one of these cosmic giants, it might resemble only one district within an unimaginably vast city. Yet the stars tell only part of the story. Surrounding every giant galaxy lies an invisible halo of dark matter extending far beyond the visible stars. These halos contain far more mass than everything shining inside them. Gravity originates not only from what we can observe, but from enormous unseen structures patiently surrounding each galaxy. Without these invisible halos, galaxies themselves might never have formed. The sleeping giant extends far beyond the light. One of the most fascinating examples resides inside the Coma cluster, located over 300 million light-years from Earth. Containing more than 1,000 galaxies, Coma is immersed in a vast cloud of superheated plasma, the invisible ocean we explored earlier. Its galaxies move at astonishing speeds, often exceeding several million kilometers per hour. Only an extraordinary amount of gravity prevents them from escaping. Yet when astronomers carefully measured all the visible matter, something astonishing appeared. There simply wasn't enough. The galaxies should have flown apart long ago. Something unseen was holding the entire cluster together. Dark matter revealed its presence once again. Like an invisible mountain beneath calm water, it quietly supported everything above. Elsewhere, even stranger sleeping giants exist. Astronomers have discovered enormous concentrations of matter known as great attractors. These are not single objects. Instead, they are vast regions containing immense quantities of galaxies and dark matter whose combined gravity influences neighboring galaxy groups across astonishing distances. Our own Milky Way is slowly moving toward one such region. Not rapidly, only about 600 kilometers each second. In everyday life, that sounds unimaginably fast. On cosmic scales, it is simply another patient drift. For decades, the Great Attractor remained mysterious because much of it lies hidden behind the dense stars and dust of the Milky Way itself. It was as though a great mountain stood behind thick morning fog. We could not see it directly. Only the movements of everything around it revealed its existence. Modern observations have gradually uncovered more of this hidden landscape. Yet many mysteries remain. Perhaps the greatest sleeping giants still lie beyond our present understanding. There is something profoundly peaceful about these enormous structures. They remind us that influence does not always require motion. A mountain shapes rivers without ever walking. The moon guides Earth's tides without speaking. Gravity organizes galaxies without making a sound. The largest builders in existence work with astonishing patience. 1 billion years. Another billion. Another. The universe never appears rushed. It simply allows gravity enough time. Even black holes, often imagined as endlessly hungry monsters, spend most of their existence waiting. Their greatest influence comes not through constant destruction, but through the quiet curvature they create in space itself. Nearby stars adjust their paths. Gas slowly changes direction. Entire galaxies organize themselves around invisible centers. Power often appears gentler than we expect. As astronomers continue mapping the observable universe, they repeatedly discover that the visible cosmos resembles only the surface of a much deeper reality. Bright stars decorate invisible foundations. Galaxies illuminate hidden frameworks. Clusters drift through oceans of unseen matter. Everything beautiful rests upon structures we cannot directly observe. Perhaps that is one of nature's favorite lessons. The strongest foundations are often invisible. Forests depend upon unseen roots. Coral reefs rely upon tiny organisms hidden beneath the waves. Human life itself depends upon invisible atoms quietly performing their endless work. The universe follows the same quiet philosophy. Its greatest architecture remains largely concealed. Its largest giants sleep patiently beyond the stars, and while we gaze upward, admiring brilliant galaxies scattered across the darkness, those ancient invisible giants continue waiting, almost motionless, almost forgotten, quietly holding together some of the largest kingdoms the universe has ever known. Number 6. The worlds that orbit nothing familiar. Imagine standing beneath a sky where your sun is no longer part of any galaxy. Only endless darkness surrounds your world. Imagine waking before sunrise. You step outside expecting the familiar stars overhead. Instead, the sky is almost empty. No glowing band of the Milky Way. No neighboring constellations. No distant galaxies scattered across the heavens. Only one brilliant sun warming your world. And beyond it, an ocean of darkness stretching for millions of light years in every direction. Your planet still follows its yearly orbit. The seasons still change. The oceans still rise and fall. Life continues much as it always has. Yet, your entire solar system has become a lonely island drifting through the greatest emptiness in the universe. It sounds impossible. After all, every star belongs somewhere. Every planet must surely orbit inside a galaxy, or so we once believed. Tonight, we'll explore one of the strangest possibilities modern astronomy has revealed. Worlds that may continue circling perfectly ordinary stars, long after those stars have left every galaxy behind. Because sometimes, home is not a place. It is simply the gravity that keeps a family together. When we picture the universe, we often imagine galaxies as permanent homes. The Milky Way shelters hundreds of billions of stars. Each follows its own graceful path around the galactic center. Planets quietly accompany them. Entire solar systems spend billions of years moving together through familiar stellar neighborhoods. it feels wonderfully stable. Yet galaxies are not peaceful forever. Throughout cosmic history, they have been constantly interacting. Small galaxies fall into larger ones. Massive spirals slowly approach one another. Clusters gather. Gravity rearranges everything. Most of these encounters unfold so slowly that no human lifetime could ever notice the change. But over billions of years, entire galactic maps are rewritten. During these immense encounters, something remarkable occasionally happens. Most stars survive completely unharmed. The distances between them remain so vast that direct collisions are extraordinarily rare. Instead, gravity itself becomes the great sculptor. As galaxies pass one another, enormous gravitational forces stretch their spiral arms into delicate ribbons of stars. Some stars are gently pulled inward toward new homes. Others are flung outward, far outward, sometimes fast enough to escape both galaxies entirely. Imagine two dancers spinning while holding long ribbons. As they separate, one ribbon suddenly slips free and floats into the darkness beyond the stage. The ribbon remains intact. Only its surroundings have changed. Entire solar systems may experience something surprisingly similar. The star escapes. Its planets remain loyal. Their orbits barely change. The local family survives. Only the neighborhood disappears. Astronomers have already observed countless stars wandering between galaxies. Many were stripped away during ancient galactic mergers. Others were ejected through close encounters involving multiple stars or even supermassive black holes. If those stars possessed planetary systems before their departure, there is every reason to believe many of those planets continued orbiting exactly as before. Gravity inside a solar system is astonishingly resilient. The bond between a planet and its parent star is far stronger than the star's gentle attachment to its galaxy. Imagine holding a small stone tied securely to a string while walking across a field. Whether you remain inside the field or leave it entirely makes no difference to the stone. It continues circling your hand. The solar system behaves much the same way. Galaxies provide the scenery. Stars provide the true home. This raises one of the most fascinating possibilities in modern astronomy. Could life exist on one of these lonely worlds? At first, the idea seems discouraging. Without a galaxy nearby, the night sky would appear astonishingly empty. There would be no bright river of stars crossing overhead. Perhaps only one faint spiral galaxy would glow far in the distance, little more than a delicate smudge barely visible to the naked eye. Civilizations living there might never suspect the true richness of the universe. Their telescopes would reveal mostly darkness. Yet darkness itself does not prevent life. Life depends primarily upon energy. As long as the parent star continues shining, the planet receives warmth. Liquid water can still exist. Atmospheres remain stable. Forests, if such things evolved there, could still grow beneath familiar sunlight. Children might still laugh beneath blue skies. Rain could still fall. Birds might still sing. From the ground, daily life could appear wonderfully ordinary. Only the night would tell a different story. Imagine standing beneath that lonely sky. Our own ancestors looked upward and immediately found countless questions. Why do the stars move? What are the constellations? Where does the Milky Way lead? An isolated civilization might ask very different questions. Why is the universe so empty? Why is there only one distant galaxy? Are we completely alone? Ironically, discovering modern cosmology might become vastly more difficult. On Earth, the Milky Way itself first revealed that we lived inside something far larger than our solar system. Without that glowing band overhead, recognizing the existence of galaxies could require centuries or even millennia longer. Knowledge often depends upon perspective. Where you happen to be shapes the questions you are able to ask. Perhaps that is one of the quiet lessons of the universe. Even loneliness can influence science. these wandering worlds would also experience extraordinary nights. Without billions of nearby stars, true darkness would finally reveal itself. The faint glow produced by distant galaxies would almost disappear. Intergalactic space is among the darkest environments nature has ever created. An observer standing there would witness a sky unlike any humans have ever known. Silence made visible, darkness almost without limit. Yet perhaps beauty would remain. One brilliant sun during the day, one faint galaxy decorating the horizon at night. Sometimes simplicity carries its own kind of wonder. There is another possibility, even stranger still. As galaxies continue merging over billions of years, stars may repeatedly change homes. A solar system could begin inside a small dwarf galaxy. Later, it might become part of the Milky Way after a merger. Billions of years afterward, it could join the giant galaxy formed when the Milky Way and Andromeda unite. Eventually, another close encounter might fling it back into intergalactic space. One star, several different galaxies. Then, none at all. Its planets quietly following every step of the journey. The universe rarely tells simple stories. Everything remains connected through gravity's patient choreography. Even our own sun participates in this great dance. Roughly 4.5 billion years from now, the Milky Way and Andromeda will begin merging. The solar system will almost certainly survive. Its orbit around the galactic center may change dramatically. Our night sky will transform beyond recognition. Towering rivers of stars will fill the heavens as the two galaxies slowly intertwine. Could the sun eventually be thrown outward during that immense encounter? Astronomers believe the probability is relatively small. Most likely, the solar system will remain inside the newly formed giant galaxy. Yet, the possibility is not zero. Gravity occasionally writes wonderfully unexpected endings. Perhaps somewhere among the countless stars visible tonight, a future intergalactic traveler is already quietly orbiting its galactic center, unaware that billions of years from now, it will leave everything familiar behind. There is something deeply comforting hidden within these wandering worlds. We often imagine that belonging comes from our surroundings. The universe gently suggests otherwise. A planet belongs to its star. A moon belongs to its planet. A family belongs to one another. Everything else may change. Galaxies merge. Stars wander. The architecture of the cosmos slowly transforms, yet the smallest bonds often endure the longest. And somewhere, beyond the crowded cities of the Milky Way, a quiet world may already be circling its faithful sun, alone beneath an almost empty sky, patiently drifting through the endless darkness, carrying its little island of warmth across the silent ocean between galaxies. Number 7. The first roads ever built. In the universe. Long before the first galaxy existed, gravity had already begun drawing invisible roads that would shape the entire cosmos. Imagine opening a map of a country that hasn't been built yet. There are no cities, no villages, no bridges, no roads, only empty land stretching beyond the horizon. And yet somehow, the highways are already there, invisible, waiting. The people who will one day travel them have not even been born. The cities that will one day flourish do not yet exist, but the routes connecting them have already been quietly decided. The universe may have begun in much the same way, long before the first stars illuminated the darkness, long before galaxies spun their graceful spiral arms, long before planets carried oceans or life. Invisible pathways were already taking shape. They carried no travelers, no light, no matter, at least not yet. But gravity had already begun sketching the blueprint of everything that would follow. Tonight, we'll journey farther back than ever before, to a time before galaxies, before starlight, before the familiar universe itself. We'll discover how the first roads in existence were never built by engineers, but by gravity patiently shaping the youngest cosmos into the magnificent universe we know today. If you're enjoying these relaxing stories from across the cosmos, subscribing helps us continue exploring one peaceful mystery at a time. When we look around our own world, roads always arrive after civilization. People settle, villages appear, trade begins. Eventually, paths connect one place to another. Roads are usually the consequence of life. The universe chose the opposite order. Its roads appeared before there was anywhere to travel. To understand how, we must return to a universe only a tiny fraction of a second after the Big Bang. At first, everything seems almost unimaginably smooth. Matter spreads through space with remarkable uniformity. The young universe glows brilliantly with energy. There are no recognizable structures, no galaxies, no stars, no planets, only a vast ocean of particles expanding in every direction. Yet hidden within that remarkable smoothness were tiny imperfections. If the early universe had been perfectly even, nothing interesting would ever have happened. No galaxy would have formed, no star would have ignited, no planets would have existed, and no one would ever have looked upward to wonder. Fortunately, perfection was never nature's plan. Scattered throughout the newborn universe were incredibly small fluctuations in density. Some regions contained just a little more matter than others. The differences were astonishingly tiny, only about 1 part in 100,000. To us, they would seem almost meaningless. But gravity notices everything. Even the slightest imbalance matters. Where a little more matter gathered, gravity became just a little stronger. That stronger gravity attracted more matter. As more matter arrived, gravity strengthened again. The process fed itself endlessly, not quickly, not violently, simply with extraordinary patience. Imagine rainwater falling across an almost perfectly flat landscape. At first, the ground appears smooth. Then, one tiny depression gathers slightly more water than the rest. Soon, another drop flows toward it, then another. Eventually, a small stream begins forming. Other streams join. A river quietly appears where none existed before. Gravity built the universe in almost exactly the same way. The first invisible roads were not carved into rock. They were carved into space itself. Much of this construction involved something humanity still cannot see directly: dark matter. Although invisible, dark matter outweighs ordinary matter by roughly 5 to 1. It neither shines nor reflects light, yet it possesses gravity. And in the young universe, gravity was exactly what mattered most. Dark matter began gathering into enormous halos long before ordinary gas had cooled enough to form stars. Slowly, these halos connected through delicate filaments stretching across unimaginable distances. The first highways had appeared. No traffic yet moved upon them. Only invisible architecture quietly awaiting the future. When ordinary hydrogen finally cooled, it naturally followed those gravitational pathways. Like rainwater flowing into ancient river valleys, gas drifted along the invisible filaments. Some streams merged, others divided. Millions of years became hundreds of millions. Eventually, enough hydrogen accumulated at certain intersections for the first stars to ignite. The first galaxies were born. This is why galaxies rarely appear scattered randomly across the sky. They grow where gravity first laid its ancient roads. Even today, when astronomers map millions of galaxies, they find something extraordinary. The galaxies trace enormous filaments crossing the observable universe. Between them lie vast cosmic voids, peaceful regions containing remarkably little matter. The overall pattern resembles a gigantic web stretching across billions of light years. Every bright galaxy marks another destination along highways first drawn almost 14 billion years ago. In a very real sense, modern galaxies still follow directions written during the universe's earliest moments. Perhaps the most astonishing part of this story is how slowly everything happened. Human beings often associate creation with sudden events. A building rises, a bridge opens, a city expands. The universe preferred another rhythm entirely. Gravity never hurried. It allowed billions of years for tiny fluctuations to become galaxies, billions more for galaxies to gather into clusters, still more for stars to enrich space with heavier elements. Only then could rocky planets appear. Only much later could life begin asking where it all came from. The roads arrived first, the travelers followed. Modern computer simulations beautifully recreate this ancient history. Astronomers begin with an almost perfectly smooth universe. They allow gravity to work according to Einstein's equations. Nothing more. No additional instructions. No hidden adjustments. Slowly, faint filaments emerge. Then intersections. Then galaxies. Then clusters. Eventually, the simulation produces something astonishingly similar to the real universe observed by our most powerful telescopes. It is one of science's quiet triumphs, not because it reveals every mystery, but because it shows that patience alone can build unimaginable beauty. The first roads never required architects. Gravity was enough. Even our own Milky Way owes its existence to one of these ancient pathways. Billions of years ago, invisible rivers of hydrogen slowly flowed toward a growing dark matter halo. Generation after generation of stars formed. Some exploded, enriching space with oxygen, carbon, silicon, and iron. Later generations inherited those elements. Eventually, one modest cloud collapsed to form an ordinary yellow star. Around it, dust gathered into planets. One of those planets became Earth. Every mountain, every ocean, every tree, every living creature, every human thought can trace its ancestry back to hydrogen, quietly following roads laid down before the first galaxy existed. There is something profoundly humbling about that realization. The journey leading to us began unimaginably long before us. Perhaps that is why the universe often feels less like a collection of separate objects and more like a single unfolding story. Every chapter depends upon those that came before. The galaxies inherited the roads. The stars inherited the galaxies. The planets inherited the stars. Life inherited the planets. Curiosity inherited life. And now, through telescopes and quiet evenings beneath the night sky, the universe has finally become capable of reflecting upon its own beginnings. Perhaps the first roads are still being built, not because gravity has changed, but because the universe continues evolving. Galaxies continue gathering, clusters continue growing, fresh hydrogen still flows along invisible filaments. Tomorrow's stars are already drifting toward places where they have not yet been born. The map remains unfinished. The highways continue extending across expanding space. There is something deeply comforting about that thought. Roads usually exist to connect distant places. The universe seems to have built its first roads for a different purpose, not simply to connect galaxies, but to connect time itself. From tiny fluctuations in the newborn cosmos, to the stars above us tonight, to every question ever asked beneath their light. And somewhere, beyond the farthest galaxy, our telescopes can presently observe. Gravity is still quietly drawing new paths across the darkness, patiently preparing destinations that no civilization has yet imagined. One invisible road at a time. Number 8. The quiet oceans between the galaxies. The universe contains oceans larger than anything we can imagine. Not of water, but of invisible matter drifting silently through space. Imagine standing on the shore of an ocean so vast that no sailor could ever cross it. There are no waves crashing against the beach, no salty breeze, no distant horizon where the sea meets the sky. Instead, the ocean is almost perfectly invisible. You could fly through it for millions of years without realizing you had ever entered it. And yet, This silent sea contains more material than all the stars in thousands of galaxies combined. It stretches across millions of light years. It quietly feeds newborn stars. It shapes the paths of entire galaxies. It preserves the history of the universe itself. Tonight, we'll leave behind the bright islands of starlight and drift into one of the least understood realms in the cosmos. The immense oceans that exist between galaxies, places so quiet, so empty, that they seem almost forgotten. Yet, without them, the magnificent galaxies we admire in the night sky might never have existed at all. Yes, when most people imagine space, they picture emptiness. The word itself almost invites that conclusion. Empty space, nothingness, a vast vacuum stretching endlessly between distant stars. To a certain extent, that picture is true. Space is astonishingly empty compared to anything we experience on Earth. If you removed all the air from a room, the remaining vacuum would still contain far more particles than many regions between galaxies. And yet, empty does not mean completely empty. The universe rarely wastes space. Even its loneliest places contain quiet traces of matter, patiently drifting through the darkness. Between galaxies lies an extraordinary substance known as the intergalactic medium. At first glance, it hardly seems worthy of the name medium. Its particles are spread incredibly far apart. In many regions, there may be only a single hydrogen atom occupying an entire cubic meter of space. Imagine walking through a vast forest where each tree stood dozens of miles from the next. The forest would appear almost non-existent. Yet technically, the forest would still be there. The intergalactic medium behaves much the same way. It is unimaginably thin. But because the universe is unimaginably large, those tiny amounts accumulate into something extraordinary. In fact, astronomers now believe that a significant fraction of all ordinary matter in the universe does not reside inside stars or galaxies at all. Instead, it quietly drifts through these immense cosmic oceans. For centuries, humanity believed galaxies contained nearly everything important. They were the cities of the universe, the bright places, the obvious places. Everything else seemed like empty countryside. Modern astronomy has revealed something far more surprising. The countryside may actually contain much of the universe's hidden wealth. Most of these vast oceans consist primarily of hydrogen, the simplest element in nature, the same hydrogen that formed only a few 100,000 years after the Big Bang, long before stars existed, before planets, before life. Hydrogen quietly filled nearly the entire cosmos. Over billions of years, gravity gathered portions of that hydrogen into galaxies. Stars ignited. Heavy elements formed. Yet enormous quantities remained behind, patiently floating through intergalactic space, waiting, sometimes for billions of years. Eventually, gravity gently calls portions of this hydrogen toward nearby galaxies. The journey unfolds almost impossibly slowly. There are no roaring currents, no giant waterfalls, only a gradual inward drift guided by invisible dark matter filaments. The gas cools, clouds form, stars are born. In many ways, every shining galaxy resembles a living island surrounded by an ocean that continuously supplies fresh resources. Without that quiet supply, galaxies would eventually consume all their available gas. Star formation would gradually cease. The brilliant spiral arms we admire today would slowly fade into silence. The oceans between galaxies are not merely leftovers. They are reservoirs of tomorrow's stars. Yet not all of this invisible ocean remains cool. Some regions contain gas heated to astonishing temperatures, millions of degrees, far hotter than the surface of the sun. This seems impossible. How can something so hot remain invisible? The answer lies in its extraordinary thinness. Each particle carries tremendous energy, but there are so few particles that very little visible light is produced. Instead, this hot gas reveals itself mainly through X-rays or by subtly affecting light passing through it. Astronomers often call these hidden reservoirs the warm-hot intergalactic medium, or UHIM. The name sounds almost ordinary. The reality is anything but. For decades, scientists struggled with one of cosmology's greatest mysteries. Calculations suggested that much of the universe's ordinary matter had somehow gone missing. Stars accounted for only a small percentage. Galaxies themselves contained surprisingly little. Where had everything gone? Eventually, better telescopes began detecting faint signatures from the WHIM. The missing matter had not disappeared. It had simply been hiding in the quiet oceans between galaxies all along. Sometimes nature solves mysteries not by creating something new, but by revealing what was patiently waiting to be discovered. Perhaps the most remarkable aspect of these oceans is how they preserve ancient history. Unlike the busy interiors of galaxies, where stars continually reshape their surroundings, intergalactic space changes very slowly. Hydrogen clouds drifting through these immense regions may remain relatively undisturbed for billions of years. They become cosmic archives, ancient records preserving conditions from the universe's youth. Astronomers often study distant quasars to read those records. Quasars are among the brightest objects in existence. Their powerful light shines through countless hydrogen clouds before reaching Earth. Each cloud absorbs very specific colors of light. The missing wavelengths create delicate fingerprints known as the Lyman alpha forest. Rather than trees growing from soil, this forest grows from invisible hydrogen stretching across billions of light years. Every tiny absorption line marks another cloud floating peacefully between galaxies. Together, they create one of astronomy's most remarkable maps of the invisible universe. It is almost like reading shadows cast by objects we cannot directly see. These silent oceans also help explain why galaxies rarely evolve alone. Fresh gas continually flows inward. Material escapes through supernova explosions. Powerful black holes sometimes launch enormous jets that push heated gas back into intergalactic space. The relationship resembles Earth's water cycle. Water evaporates, clouds form, rain falls, rivers return water to the sea. Nothing remains isolated. The universe appears to operate through a similarly gentle circulation. Gas leaves galaxies. Gas returns. Stars are born. Stars die. Their atoms rejoin the great ocean once more. Everything participates in an endless cosmic cycle. Even our own existence is connected to these invisible seas. The hydrogen atoms inside the water you drink began their story nearly 14 billion years ago. Some may have drifted through intergalactic space for billions of years before finally becoming part of the cloud that formed our sun. The oxygen in your lungs was forged inside an ancient star. After that star died, its atoms wandered through the galaxy, eventually mixing with fresh hydrogen arriving from the intergalactic medium. Only then could Earth begin assembling the ingredients for oceans, mountains, forests, and life. In a profound sense, every living creature carries memories of those quiet oceans. There is something deeply peaceful about that thought. We often imagine the universe as a collection of separate places, stars here, galaxies there, planets somewhere else. Nature quietly tells another story. Nothing truly remains separate. Invisible oceans connect everything. Hydrogen slowly becomes stars. Stars create heavier elements. Those elements return to space. The cycle begins again. The greatest distances in existence do not divide the universe. They unite it. Perhaps that is why the cosmos feels so calm on its largest scales. Nothing hurries. Nothing is wasted. Even the emptiest places patiently prepare the future. And somewhere beyond the faint glow of the nearest galaxy, an invisible ocean continues drifting through the darkness, carrying the raw ingredients for stars that have not yet been born. patiently waiting for gravity to call them home? Number 9. The ancient fires still burning today. Some of the oldest energy in the universe has been traveling toward us since long before our own galaxy was fully born. Imagine standing beside a campfire on a quiet evening. You watch the flames dance for a while before turning away. Hours later, the fire has almost disappeared. Only a few glowing embers remain. Soft, gentle, barely visible. Yet those tiny sparks still carry the memory of the great fire that once burned brightly. The universe has its own ancient embers. They are not made of wood. They produce almost no visible light. Most people never notice them. And yet, they have been quietly glowing since nearly the beginning of time. Long before the Milky Way became the graceful spiral we know today, long before Earth existed, long before the sun had even begun to form, these ancient fires had already begun their endless journey across the expanding universe. Tonight, we'll follow those remarkable survivors, the oldest energy still traveling through space, the fading echoes of the universe's first great light, and the extraordinary story of how the oldest fire in existence continues touching Earth every single moment. When we think about ancient light, our minds naturally picture old stars, perhaps a red giant shining peacefully for billions of years, or a distant galaxy whose light began traveling toward Earth before dinosaurs walked our planet. Those are certainly ancient, but they are not the oldest light we can see. To find that, we must journey much farther back beyond galaxies, beyond stars, beyond planets, back to a universe only about 380,000 years old. Compared to its current age of nearly 13.8 billion years, the cosmos was still an infant. Yet something extraordinary had just happened. The great cosmic fog had finally lifted. Electrons combined with atomic nuclei to form the first stable hydrogen atoms. Light, trapped for hundreds of thousands of years inside the hot plasma of the young universe, suddenly became free. For the very first time, photons could travel unhindered across space. Many of those very same photons are still traveling today. Astronomers call this remarkable glow the cosmic microwave background, or simply the CMB. It is often described as the oldest light in the universe, but perhaps another description feels even more peaceful. It is the oldest fire that has never completely gone out. Of course, it no longer resembles fire as we know it. When these photons first escaped, the universe glowed with a brilliant orange-white light. If someone could have somehow survived to witness that impossible moment, the entire sky would have shone brighter than molten metal. Every direction would have radiated warmth. There would have been no darkness anywhere, but the universe continued expanding. As space stretched, so did the light itself. Every photon lost a tiny amount of energy. Its wavelength gradually became longer. Its color slowly shifted. Orange faded toward red. Red drifted into infrared. Eventually, after billions of years of cosmic expansion, those once brilliant photons became microwaves. Today, they are completely invisible to human eyes. The great fire has cooled into glowing embers, yet the embers still remain. Remarkably, this ancient glow fills every direction in the sky. Whether you point a radio telescope toward the Milky Way, toward Andromeda, toward an apparently empty region of space, or toward the darkest corner of the observable universe, you will always detect the faint whisper of this ancient radiation. It surrounds us constantly, not because it comes from nearby objects, but because we exist inside it. In some sense, the entire observable universe still floats within the fading warmth of its earliest light. There is something deeply comforting about that image. We often think of the Big Bang as an event locked forever in the distant past. Yet part of that beginning never truly disappeared. Its oldest light still quietly washes over Earth every second. In fact, millions of these ancient photons are passing through your body right now. They do so silently, harmlessly, patiently. They have been traveling for nearly the entire age of the cosmos simply to arrive at this exact moment. Perhaps nowhere else in science do the beginning and the present feel so closely connected. The CMB also carries extraordinary information. Unlike stars, which continually change as they age, this ancient light preserves a remarkably faithful picture of the universe when it first became transparent. It is often compared to a baby photograph, not of a person, but of the entire cosmos. Modern satellites have mapped this ancient radiation with astonishing precision. Their observations reveal tiny temperature variations across the sky. Some regions are only a few millionths of a degree warmer than others. At first glance, the differences appear insignificant, yet these minute ripples became the seeds from which everything eventually grew. Every galaxy, every star, every planet, even our own solar system. The smallest irregularities inside the oldest light ultimately shaped the entire visible universe. There is another remarkable reason astronomers treasure this ancient fire. Light always travels at a finite speed. Whenever we observe distant objects, we are looking into the past. The farther away something lies, the older the light we receive. Nearby stars show us years-old light. Distant galaxies reveal billions of years. The cosmic microwave background represents the ultimate limit. Beyond it, ordinary light cannot carry us any farther back. Before that moment, the universe remained opaque. The ancient fog prevented photons from traveling freely. It is rather like standing beside a frozen lake. The ice allows you to see only as far as its surface. Everything beneath remains hidden. The CMB forms a similar surface across the entire universe. It marks the oldest moment light itself can presently reveal. What happened earlier remains one of the greatest mysteries in modern cosmology. Perhaps future discoveries involving gravitational waves or entirely new forms of astronomy will someday allow humanity to peer even deeper into cosmic history. For now, the oldest fire still burning marks the edge of our visible memory. Yet the universe contains many other ancient embers as well. White dwarf stars continue glowing long after exhausting their nuclear fuel. Neutron stars slowly radiate away their tremendous heat. Even black holes may eventually emit an almost unimaginably faint glow through a process known as Hawking radiation, although this occurs so slowly that no such emission has yet been directly detected. Again and again, nature reveals that endings are rarely sudden. Great fires become quiet warmth. Brilliant stars become gentle embers. Even the universe itself seems to prefer slow transitions over abrupt conclusions. Perhaps that is one of the most beautiful lessons hidden among the stars. Nothing truly vanishes all at once. Light continues traveling long after its source changes. Energy patiently transforms into gentler forms. The past never completely leaves the present. It simply grows quieter. There is something wonderfully reassuring about that thought. Every sunrise carries sunlight that left the sun over 8 minutes ago. Every star tells a story years, centuries, or millennia old. Every distant galaxy sends us memories billions of years in the making. And beyond them all, the oldest fire in existence still whispers softly across the heavens. It no longer blinds the universe with brilliant light. It no longer fills space with overwhelming heat. Instead, it has become something gentler, a quiet glow, an ancient warmth, a peaceful reminder that the beginning of everything has never entirely disappeared. And somewhere above us tonight, countless ancient photons continue crossing the expanding universe. The last glowing embers of a fire that began before the Milky Way was fully born, still burning, still traveling, still telling the oldest story the cosmos has ever remembered. Number 10, the gravity that built everything. Every star you've ever seen may owe its existence to an invisible force that spent billions of years quietly building the universe. Imagine walking through an enormous cathedral. Sunlight pours through the windows. Nothing Towering columns rise toward the ceiling. Every arch fits perfectly into place. The building feels timeless, so complete that it almost seems as though it has always existed. But hidden beneath the polished stone lies something no visitor ever sees. A foundation, silent, invisible. Without it, every wall would collapse, every window would shatter, every beautiful detail would disappear. The universe has a foundation much like that. It cannot be touched. It cannot be seen. It never shines like a star. It never announces its presence with brilliant colors. Instead, it spends billions of years quietly pulling, patiently gathering, endlessly shaping. Every galaxy, every planet, every moon, every grain of cosmic dust. Without this invisible architect, there would be no night sky, no constellations, no Earth, no oceans, no life. Tonight, we'll follow the quiet force that built everything we know, not through sudden explosions or spectacular miracles, but through an almost unimaginable patience that continues shaping the universe even now. Whenever people think about powerful forces in nature, explosions often come to mind. Volcanoes reshape landscapes. Lightning splits ancient trees. Supernovae briefly outshine entire galaxies. Power seems dramatic, loud, immediate. Gravity tells a very different story. It almost never rushes. In fact, gravity is the weakest of nature's 4 known fundamental forces. A tiny refrigerator magnet can easily overcome the gravitational pull of our entire planet on a small paperclip. That sounds almost unbelievable. How can something so weak become the dominant architect of the universe? The answer lies in one remarkable characteristic. Gravity never stops. Unlike many other forces, gravity only attracts. It never grows tired. It never switches off. Every tiny pull adds to every other tiny pull. Minute influences accumulate. Hours become centuries. Centuries become millions of years. Millions become billions. Eventually, the weakest force becomes the strongest builder. Imagine placing a single grain of sand onto an empty beach. Nothing changes. Add another. Still nothing noticeable. Continue patiently for thousands of years. Eventually, dunes appear. Continue for millions. Entire coastlines emerge. Gravity builds the universe in almost exactly the same way. Its greatest strength has never been power. Its greatest strength is patience. Shortly after the Big Bang, the young universe contained little more than hydrogen, helium, dark matter, and light. No galaxies decorated the darkness. No stars warmed empty space. No planets circled peaceful suns. Everything that would someday exist remained scattered across an expanding cosmos. Yet gravity had already begun its quiet work. Tiny differences in density, almost unimaginably small, slowly attracted additional matter. Regions containing just slightly more material became just slightly heavier. That additional mass strengthened gravity. Stronger gravity attracted still more matter. The process repeated endlessly. No explosions were required, only time. Over hundreds of millions of years, invisible halos of dark matter grew steadily larger. Ordinary hydrogen followed those gravitational valleys, flowing gently into their embrace. Clouds became denser, pressure increased, temperatures slowly rose. Then, after immense ages of quiet preparation, the first stars ignited. Gravity had transformed invisible gas into brilliant light. Every star that has ever existed tells the same basic story. A cloud drifts. Gravity gathers it. The cloud becomes denser. Its own weight compresses its center. Temperatures climb into the millions of degrees. Eventually, hydrogen nuclei begin fusing into helium. A star is born. Remarkably, gravity creates the very conditions that allow another force to oppose it. The nuclear fusion inside a star pushes outward. Gravity pulls inward. For billions of years, those two opposing influences maintain an elegant balance. Every peaceful sunrise on Earth exists because gravity and nuclear fusion continue negotiating with extraordinary precision inside our sun. Too much gravity, and the star collapses. Too little, and it never ignites at all. Nature seems to delight in balance. Gravity also determines how planets appear. Around every newborn star, a vast disk of gas and dust quietly rotates. Tiny grains collide. Some stick together. Small rocks become larger. Gravity slowly gathers these growing fragments into worlds. Mountains, continents, oceans, atmospheres. Every planet begins with gravity patiently introducing one tiny particle to another. Even our own bodies quietly reveal gravity's influence. The iron flowing through your blood formed inside ancient stars. Those stars existed because gravity compressed hydrogen clouds billions of years ago. The oxygen you breathe, the calcium strengthening your bones, the carbon inside every living cell. Each owes its existence to stars that gravity patiently assembled long before Earth existed. In a very real sense, gravity helped write the chemistry of life itself. The same quiet force continues shaping galaxies. The Milky Way rotates because gravity binds hundreds of billions of stars together. Without it, each star would simply continue moving through space independently. Our familiar spiral galaxy would dissolve into an expanding cloud of lonely suns. Even entire galaxy clusters remain intact only because gravity quietly prevents their members from drifting away. Yet perhaps gravity's greatest masterpiece is something we cannot directly see. Dark matter. Although invisible, dark matter provides much of the gravitational framework supporting galaxies and clusters. It behaves almost like the steel skeleton inside a skyscraper. Visitors admire the glass, the architecture, the sunlight reflecting from polished surfaces. Few ever think about the hidden framework quietly carrying the entire structure. The universe appears remarkably similar. Visible matter decorates invisible foundations. Modern astronomers have mapped enormous regions of space where galaxies gather into delicate filaments stretching across hundreds of millions of light years. Between them lie enormous voids. Together, they resemble an immense cosmic web. Gravity drew every thread, patiently, without ever announcing its work. There is another side to gravity's story that often surprises people. Gravity does not merely build. Eventually, it also transforms. Massive stars exhaust their nuclear fuel. Without enough outward pressure, gravity gently reclaims control. Some stars shrink into white dwarfs. Others collapse into neutron stars. The most massive become black holes. At first glance, these endings seem destructive. Yet they also prepare new beginnings. Supernova explosions scatter heavy elements across nearby space. Future stars inherit those elements. Future planets form from enriched clouds. Future life becomes possible. Gravity closes one chapter only to begin another. Nothing is truly wasted. Even black holes, often imagined as cosmic monsters, demonstrate gravity's extraordinary creativity. Their immense gravitational pull bends space itself. Light changes direction. Time flows differently near their event horizons. Entire galaxies organize around supermassive black holes quietly resting at their centers. The universe repeatedly reveals that gravity's greatest achievements come not through violence, but through elegant structure. Perhaps this is why Einstein's description of gravity feels so beautiful. Rather than imagining gravity as an invisible rope pulling objects together, general relativity describes mass as gently curving space and time themselves. Planets simply follow those curves. Stars drift along invisible valleys. Galaxies navigate landscapes sculpted by mass. Everything moves naturally, like leaves floating along the gentle curves of a peaceful river. The universe does not force its travelers, it quietly guides them. There is something deeply comforting hidden within that idea. We often think that meaningful change requires dramatic action. nature suggests otherwise. Mountains rise grain by grain. Forests grow leaf by leaf. Coral reefs expand creature by creature. The universe itself was built one gentle pull at a time. Patience created everything we love beneath the night sky. Perhaps gravity is not merely a force. Perhaps it is the universe's favorite way of expressing patience. It never hurries. It never complains. It simply continues gathering scattered pieces into something beautiful. And somewhere, far beyond the stars we can see tonight, gravity is still quietly at work, drawing invisible clouds together, preparing tomorrow's galaxies, tomorrow's suns, tomorrow's worlds, one gentle pull at a time. Number 11, the last places to change. While stars are born and galaxies collide, some corners of the universe remain almost exactly as they were billions of years ago. Imagine walking through an ancient forest. Around you, seasons come and go. Trees fall, new saplings rise, rivers slowly carve fresh paths through the landscape. Everything changes, everything grows older. Yet, hidden deep within the forest stands a single stone. It has rested in exactly the same place for thousands of years. Storms have passed, empires have risen and vanished. Generations have come and gone. The stone simply remains, quiet, patient, almost untouched by time. The universe has places very much like that. While galaxies merge in spectacular collisions, while stars are born in brilliant clouds of gas, while black holes quietly reshape entire galaxies, some regions of the cosmos appear to have changed astonishingly little since the universe was still young. They are not frozen. Time still flows there. Gravity still works. Light still travels. But compared with the restless activity elsewhere, these places seem almost timeless. Tonight, we'll visit the quietest neighborhoods in existence, the places where change itself arrives more slowly, the ancient corners of the universe that continue preserving memories from billions of years ago. Because sometimes, the greatest stories are not written by things that change quickly, but by those patient enough to remain. The universe often feels like a place of constant motion. Planets orbit stars, stars orbit galaxies. Galaxies gather into clusters. Clusters slowly drift toward one another. Nothing appears completely still. Even the Earth beneath our feet races through space at extraordinary speeds. Yet motion does not always mean transformation. A clock's hands move every second. A mountain may barely change over an entire lifetime. Likewise, some parts of the universe evolve at astonishingly different rates than others. Astronomers sometimes compare cosmic history to weather. Some places resemble busy coastlines where storms constantly reshape the landscape. Others resemble ancient deserts where almost nothing changes for thousands of years. The same universe contains both. One of the quietest examples lies within certain dwarf galaxies. These tiny galaxies contain only a few million stars compared with the hundreds of billions inside the Milky Way. Many formed very early in cosmic history. Then, for reasons astronomers are still studying, they simply slowed down. Their supplies of cold hydrogen gradually disappeared. Without fresh gas, new stars could no longer form efficiently. The galaxies did not explode. They did not vanish. They simply stopped growing. Today, many contain stars that are nearly as old as the universe itself. Looking at them is almost like opening a photo album whose newest picture was taken billions of years ago. Every star quietly remembers an era when the universe itself was still young. Some of these dwarf galaxies orbit much larger galaxies like silent companions. Others drift in relative isolation. Because they have experienced relatively few dramatic encounters, they preserve ancient chemical compositions that have remained almost unchanged since their earliest days. Astronomers treasure these quiet systems. They are living fossils, not fossils made of stone, but galaxies made of memory. Even inside the Milky Way, remarkable survivors exist. Scattered throughout our galaxy are globular clusters. Each contains hundreds of thousands of stars packed into beautiful spherical swarms. Many of these stars formed over 12 billion years ago. That means they were already ancient long before the sun existed, long before Earth formed, long before life appeared. The stars inside globular clusters are among the oldest continuously shining objects in the universe. For billions of years, they have circled the Milky Way together, preserving much of their original character. Standing on a planet inside one of these clusters would produce a breathtaking sky. Thousands of stars would blaze overhead, far brighter than anything visible from Earth. Yet, despite that dazzling appearance, almost every one of those stars would be quietly old, stable, patient, their most dramatic days already far behind them. Elsewhere, even larger quiet regions exist. Between the enormous filaments of the cosmic web lie cosmic voids. We have visited these immense empty spaces before, but now we see them from another perspective. Not simply as places lacking galaxies, but as places where evolution itself unfolds remarkably slowly. Inside crowded galaxy clusters, gravity constantly pulls galaxies together. Collisions occur, gas heats, stars are born, black holes awaken, everything interacts. Inside cosmic voids, however, encounters become exceedingly rare. A lonely galaxy drifting through one of these vast regions may avoid close interactions for billions of years. Without neighboring galaxies disturbing its structure, it continues evolving gently, patiently, almost peacefully. Imagine two gardens. One sits beside a busy road where people constantly pass through. The other rests on a distant mountainside, visited only by the occasional breeze. After many years, the second garden still resembles the day it was planted. The universe keeps gardens like that. Another remarkable example comes from the oldest stars themselves. Astronomers have discovered individual stars containing extraordinarily small amounts of heavy elements. These stars formed before many generations of supernova explosions had enriched the universe with carbon, oxygen, iron, and other familiar atoms. Their chemical composition acts like an ancient fingerprint. By studying them, scientists glimpse conditions that existed shortly after the first stars began illuminating the cosmos. Some of these stellar elders have survived for over 13 billion years, quietly burning, patiently shining, long enough to witness nearly the entire history of the observable universe. There is something profoundly moving about that thought. While civilizations rise and disappear in the blink of cosmic time, one small star simply continues glowing. The universe also preserves ancient memories in unexpected places. Far beyond Neptune lies the Oort cloud, a vast spherical shell thought to contain trillions of icy bodies. Although no spacecraft has yet reached it, astronomers believe these distant objects have changed very little since the solar system formed 4.6 billion years ago. Protected by extreme cold and extraordinary distance, they remain frozen archives from the earliest chapters of our planetary history. Each icy object may preserve material older than every mountain on Earth, older than every ocean, older than life itself. Sometimes distance becomes nature's greatest form of preservation. Even light participates in this quiet conservation. As we explored earlier, the cosmic microwave background still surrounds the universe today. Those ancient photons have traveled for nearly 8 billion years with astonishing faithfulness. They have crossed expanding space, past countless galaxies, flowed around clusters of dark matter. Yet they continue carrying a nearly unchanged image of the infant universe. The oldest photograph in existence has never stopped arriving. Perhaps that is why astronomers often describe the universe as a remarkable balance between change and memory. Stars constantly manufacture new elements, Galaxies reshape themselves through mergers. Black holes grow. Space expands. Yet, alongside all this activity, certain places quietly preserve the past. Without them, much of cosmic history would have disappeared forever. Nature rarely destroys every trace of its beginnings. It always seems to leave a few careful reminders behind. There is something deeply reassuring hidden within these ancient places. Our own lives often feel filled with constant change. Days become years. Children become adults. Cities transform. Technology advances almost faster than memory itself. The universe gently reminds us that not everything must change quickly. Some things grow beautiful precisely because they endure. An old tree, a familiar coastline, a beloved melody, or a tiny ancient galaxy quietly shining exactly as it did billions of years ago. Perhaps permanence has its own quiet kind of wisdom, while the rest of the cosmos races forward. A few patient corners continue holding the memories of where everything began, and somewhere beyond the brilliant spiral arms of countless galaxies, an ancient cluster of stars still circles in silence. A forgotten dwarf galaxy continues drifting through the darkness. A lonely cloud of pristine hydrogen patiently waits untouched, keeping watch over a universe that never truly stops changing. By changing, almost not at all. Number 12, the hidden blueprint of the cosmos. The universe was never random. Beneath every galaxy lies an invisible design that has guided cosmic history since the very beginning. Imagine standing inside an enormous cathedral after everyone has gone home. The silence is complete. Moonlight filters softly through the stained glass. At first, the building feels almost mysterious, as though its towering arches and graceful pillars appeared by chance. But then you notice something. Every column stands exactly where it must. Every arch supports another. Every window follows a careful pattern. The beauty is not accidental. It comes from a hidden design beneath everything you can see. The universe may be the greatest cathedral ever built. At first glance, the stars appear scattered randomly across the night sky. Galaxies seem to drift wherever they please. Clusters appear here. Empty space stretches there. Everything feels wonderfully chaotic. Yet the deeper astronomers have looked, the more another picture has emerged. An invisible architecture, a cosmic blueprint, one that began taking shape almost as soon as the universe itself was born. Tonight, we'll follow the quiet design hidden beneath everything we've explored together. The invisible framework connecting galaxies, the patient force guiding matter across billions of years, and the remarkable possibility that the universe has never truly been random at all. Over the past few evenings, our journey has carried us across extraordinary places. We wandered through galaxies that continue growing long after their neighbors have grown quiet. We followed lonely stars crossing the darkness between galaxies. We discovered invisible bridges carrying fresh hydrogen toward newborn suns. We watched forgotten beams of light continue journeys that may never end. We visited sleeping giants whose gravity quietly organizes entire clusters of galaxies. We imagined lonely worlds orbiting stars far from every familiar sky. We traced the first invisible roads laid down before galaxies even existed. We drifted across silent oceans of intergalactic gas. We listened to the oldest light still whispering from the beginning of time. We watched gravity patiently assemble stars, planets, and galaxies. And finally, we rested in ancient corners of the cosmos where almost nothing has changed for billions of years. At first, these stories may seem unrelated. A lonely star, an ancient photon, a quiet galaxy, a hidden river of hydrogen. Yet each chapter quietly points toward the same remarkable truth. Nothing exists alone. Everything belongs to something larger. Imagine looking closely at a single leaf. Its delicate veins appear beautiful. Then you step back and notice the entire tree. Step farther still, and the forest comes into view. Climb high enough, and rivers, mountains, and valleys begin connecting into a single landscape. Perspective transforms scattered details into meaningful patterns. Astronomy has experienced exactly the same revelation. For centuries, galaxies appeared to be isolated islands floating through empty space. Then, larger telescopes revealed clusters. Later observations uncovered superclusters. Eventually, astronomers discovered enormous filaments connecting everything into the vast cosmic web. Today, this invisible framework stretches across the observable universe like an unimaginably delicate network. The galaxies themselves are almost decorations. The hidden architecture beneath them tells the deeper story. Dark matter provides much of that architecture. Although invisible, it quietly outweighs ordinary matter throughout the cosmos. Shortly after the Big Bang, dark matter began gathering into tiny concentrations. Those concentrations slowly merged into larger halos. Filaments formed between them. Ordinary hydrogen naturally followed those invisible paths. Stars eventually ignited. Galaxies emerged. Clusters assembled. Every beautiful object we admire today grew upon foundations established billions of years earlier. It is rather like ivy climbing across an ancient stone wall. Most visitors notice the leaves. Few stop to consider the structure quietly supporting everything underneath. The universe asks us to do exactly that. Look beneath the light. Perhaps one of the most extraordinary discoveries of modern cosmology is that remarkably simple rules can create astonishing complexity. Gravity pulls, matter responds, time passes, again and again. Nothing more dramatic is required. Given enough patience, tiny fluctuations become galaxies. Galaxies become clusters. Clusters trace enormous filaments. Life eventually appears on one ordinary planet, orbiting one ordinary star. Complexity emerges naturally from astonishing simplicity. Nature rarely wastes effort. Even the apparent emptiness between galaxies contributes to the design. The great voids separating cosmic filaments are not mistakes. Without them, the web itself could not exist. The brightest structures become meaningful only because quiet darkness surrounds them. Artists understand this well. Music depends as much upon silence as sound. The universe seems to share that same quiet wisdom. Light and darkness, matter and emptiness, growth and stillness. Everything works together. Another beautiful aspect of this cosmic blueprint is that it never truly finishes. Unlike a completed building, the universe continues evolving. Fresh hydrogen still flows through invisible filaments. Galaxy clusters continue growing. Stars continue forming. Even today, gravity quietly edits the architecture. The blueprint remains alive. Perhaps that is why the universe never feels mechanical. It behaves less like a finished machine and more like an endless garden. Its pathways remain recognizable. Its patterns remain consistent. Yet every generation of stars creates something new. Every galaxy writes another chapter. The design provides direction, not rigid instructions. There is a wonderful humility hidden inside this realization. Human beings often search for dramatic explanations. We expect the universe to reveal enormous secrets through spectacular events. Instead, its greatest achievement may simply be consistency. The same gravity that guided the first hydrogen clouds still holds your feet to Earth. The same physical laws governing distant galaxy clusters quietly shape falling rain. The same atoms forged inside ancient stars now compose every heartbeat. Nothing has been separated. Everything belongs to one continuous story. Perhaps that is why looking into the night sky feels strangely familiar. The stars appear distant, yet they obey the very same laws shaping our own existence. The universe never became something different. It simply became larger, richer, more intricate. Its blueprint remained beautifully consistent throughout. One day, far in the future, many of today's galaxies will have merged. Others will disappear beyond the observable horizon as space continues expanding. Star formation will gradually slow. The brilliant era we now enjoy will eventually become a quieter cosmos. Yet even then, the hidden architecture will not have failed. It will simply continue carrying the universe into its next chapter. Every blueprint exists not merely to create a beginning, but to guide an unfolding story. Perhaps that is the greatest lesson our journey has quietly offered. We began by wondering about lonely galaxies, invisible rivers, forgotten light, sleeping giants, ancient roads, silent oceans, and timeless places. In the end, each mystery turned out to be another piece of the same remarkable design. Not separate stories. One story, seen from different directions. And perhaps that is true beyond astronomy as well. The universe rarely builds through isolated miracles. Instead, it patiently connects countless small things into something unimaginably beautiful. A single hydrogen atom becomes part of a cloud. The cloud becomes a star. The star creates heavier elements. Those elements form planets. One planet becomes home to living creatures. One of those creatures looks upward and begins asking questions. Perhaps the universe's hidden blueprint was never simply about arranging galaxies. Perhaps it was also about creating the possibility that, one quiet evening, the cosmos might finally become aware of itself. So as tonight's journey comes gently to an end, remember that every star above you, every galaxy beyond them, and every silent ocean of space belongs to the same magnificent design. A design still unfolding, still growing, still quietly writing new chapters across the darkness. And if these gentle explorations help you end your evening with a little more wonder, consider subscribing, and I'll be here for our next quiet journey through the universe. Until then, sleep peacefully beneath the stars. They are far older than us, far larger than us. Yet somehow, after billions of years of quiet evolution, they have led us here, to this moment of wonder beneath the same timeless sky.